Maths educational video. Let me give you a quick introduction to functions of several variables. We begin with a quick revision. Suppose we have a function in one unknown, y equals to f of x. X is known as the independent variable, y the dependent variable. That's because y depends on x through the function f. Every function has a domain. For this particular example, the domain is the set of x lying between a and b. And finally, the so-called graph of a function is the set of all the points of the form x, fx. Moving on to a function of two variables, say x and y. We let z equals to f of x, y. Now x and y are both independent variables. And z is the dependent variable because z depends on x and y through the function f. The domain for such a function would be a subset of R2, the two-dimensional space, or the xy plane. An example of D would be a rectangle, where x and y both lie between two numbers. And finally, the graph of such a function will consist of points of the form x, y, fxy. Fxy will be the z coordinate. And these points will be plotted in a three-dimensional space. The graph of a function of two variables is usually called a surface, as shown on this slide. Just a quick remark, we can define function involving more than two variables in a similar fashion. A quick example of a function of two variables is a linear function, and the graph of a linear function is a plane in a three-dimensional space. We do a quick revision. We have learned in a pre-calculus course that the equation of a plane in a three-dimensional space is of this form: ax plus by plus cz equals to d. The vector a, b, c, this column vector is called a normal vector to the plane. So for our example, x plus y plus z equals to 5, the normal vector is the vector 1, 1, 1. And we can write z in terms of x and y to get the linear function. Let's now talk about level curve, an important concept in this context. Suppose we have a surface as shown in the diagram, and we take a horizontal plane, z equals to k. Remember, z is the height of any point in the three-dimensional space. So z equals to k contains all the points that have a constant height from the xy plane, which is why it is a horizontal plane. This horizontal plane and the surface will meet along a curve. We call this curve a contour curve. Now we project this curve onto the xy plane to get the purple curve. This purple curve is known as a level curve. We consider a numerical example. Suppose the surface is given by this equation, and we are taking z to be equal to 3. Our job is to find the equation of the corresponding level curve. The level curve is on the xy plane, so it should be an equation involving x and y only. So our job is to eliminate z from these two equations. And this can be done easily by substituting z equals to 3 into the equation of the surface. Squaring both sides will lead us to this equation: x squared plus y squared equals to 16. We recognize this as an equation of a circle centered at the origin and having a radius of 4. We end the video with another example on level curve. Just for your interest, the graph of a function of two unknowns can be plotted using mathematical software such as MATLAB or Maple. Our job is to find the equation of a level curve. So let z equals to k be the horizontal plane. It will cut this surface along a curve. Our job is to eliminate z from these two equations. And that can be done easily. All you have to do is to substitute z equals to k into the equation of the surface. And that will give us the equation y equals to k over x squared. k is a positive number. Y equals to k over x squared is the equation of a hyperbola. So this is the level curve that we are trying to find.